Hi, this is Stephen Bolgiano with a technical design video for my simplified anaerobic digester. Designed for remote African savanna regions, this is an informal description of the tank portion for this project's academic and scientist collaborators. The tank is assembled with two 55-gallon steel drums and a few PVC connections. The steel material has a significant advantage over plastic for several reasons, but primarily because of the steel's ability to absorb and transfer heat, and that it doesn't deform with pressure like plastic tanks. A proper type of 55-gallon drum is closed at each end, with holes and threaded caps on top of one of the ends and no holes on the other end. Your metal worker or welder starts by cutting out the bottoms of each end, creating two circle-shaped steel pieces. Next, those cut-out circles are trimmed to be slightly less than cut in half. These pieces are spot welded deeper inside the tank to create a flow baffle. This reduces clogging up of the discharge port. There are only two locations on the tank that require cutting to weld a steel connector to. There is a 1-inch hole for the gas outlet. It uses a welded 1-inch steel male collar to connect the gas lines to. And for the loading port, there is a 4-inch hole cut to weld a 4-inch female collar to. The PVC configurations for the loading port and the discharge port screw into the threaded metal fittings welded onto the tank. The gas port has a PVC cap screwed on to the fitting that attaches to a gas line. The loading port PVC screws right in. The discharge pipe screws into the drum's pre-existing port. Not shown in these assembly steps is the water testing for the tank leaks before welding and the application of sealant coating inside and outside. The portion of the system that's in between the tank and the cook stove will be shown in detail in the next video. After I created this video, I noticed two important areas where there is a mistake. The cutout pieces of the 55-gallon drum tops used inside the tank for flow baffles needs to be spaced wider. And a very critical detail is the comparative elevations of the discharge pipe's two separate curved sections. In order to fix the elevation of the slurry inside the tank and to trap the gas in the tank from flowing out of the discharge pipe, in order to fix the elevation of the slurry and trap the gas in the tank from flowing out the discharge pipe, a water and gas trap needs to be created. In this corrected view, the bottom of the left-hand curve is slightly higher than the right-hand curve section. This completes the introduction to the basic tank construction. It's not intended to be a standalone guide. Please contact TerraDesic for more information. Thank you.